Good morning, everyone. In the last session, we studied about the polarization. So, there we get into the definition of polarization, then whether the light is in transverse nature and longitudinal nature. So, for these, we had go through some illustration by considering the two slits S1 and S2. Okay, by this we had seen whether how the transverse nature of light will be there and how what is the characteristic of longitudinal waves. Okay, then somewhat a little bit about light, how the light will be produced, whether is it a spontaneous? Yes, light is a spontaneous. Why? Because that we had seen from that we discussed from the atomic level, from the ground state to excited state, while from it degenerate from excited state to the ground state, there the light will be emitted. So this is about the light that we had discussed in our previous session. So today we will get into transverse nature of light. Transverse nature of light. Okay, so how the transverse nature of light will be there? So what we have to do? So let's consider a axis. Okay, in the axis, we are studying about polarization. We need source of light. Okay, the source of light is unpolarized. Okay, the unpolarized light is here. That source we can call this as a S. Then it is how we are getting this light from monochromatic source. We are getting this light from monochromatic source. Okay, then what we need to learn to study about this transverse nature? We need two tourmaline crystal. Two tourmaline crystal. One is A. This is the tourmaline crystal. This is the tourmaline crystal. Here the unpolarized light is here. The light rays are which are parallel to this axis. Okay, which are parallel to this axis. When it falls on this tourmaline crystal A, some of the unpolarized light, how we will indicate? We will indicate like this, sorry. Wait. We will indicate unpolarized light like this. Okay. Both parallel rays are there, and perpendicular rays also there. Okay. When it passes through this crystal, tourmaline crystal, it passes only plane waves which are parallel to this plane propagation. Okay, it absorb which are the light rays which are perpendicular to the plane of vibration. Plane of vibration. Okay, this is the tourmaline crystal. How? If I rotate this crystal, think that this is a tourmaline crystal. The light rays which are parallel to this axis of vibration, it contains both the perpendicular rays as well as parallel rays. Okay, when it passes through this tourmaline crystal, it passes only the plane vibrations. It absorbs the perpendicular vibration. If I rotate this tourmaline crystal, there is no change in intensity. this, if I rotate this tourmaline crystal, there is no change in intensity. Okay, similarly, if I kept a one more tourmaline crystal here, so what does happens? Let's see. This is the another tourmaline crystal. So this is our first crystal and this is our second crystal. Okay, when I place these parallel together, the only here only the plane vibrations are there. Again it passes through this the tourmaline crystal B. There is no change in, only plane waves are there. Again it will passes the plane waves. Okay, again it passes the plane waves. Why? Because there is here two types of waves are simply here two types of waves were there. The one type of wave which are perpendicular to the plane of vibration, which has been absorbed by the crystal A. ಇದು ಅಬ್ಸಾರ್ಬ್ ಮಾಡ್ಕೊಂಡ್ಬಿಟ್ಟೈತಿ. Then it passes only the plane vibrations. The plane, if plane vibrations passes through the crystal B, again the outcome will be the plane vibrations. Okay, this is the one thing. If I rotate the crystal B, if I rotate the crystal B, what happens? The similar process, the monochromatic source, the light which are parallel to this axis plane vibrations, okay, it absorb the perpendicular vibrations and passes only plane vibrations. If I rotate this crystal B, slowly the intensity will be decreased. Here this rays, the intensity of this light rays which will be decreases when I slowly rotate this tourmaline crystal B. Okay, when it will be 0 when the crystal A and B are perpendicular. Before they were parallel. Slowly when I rotate this crystal B, when it comes perpendicular, the intensity will be 0. If I continue the rotation, if I continue this rotation, so again there is an increase in intensity of the light. So this is how the transverse nature of light. Okay, then here it was unpolarized, then it will be polarized one. Then the plane of vibration and plane of polarization. Let's see what is plane vibration. What is plane vibration? What is plane vibration? Plane vibration in a plane, okay, which is a plane, the polarized, this is the plane which is the polarized light. The plane contains the direction of vibration. The plane contains, this is the plane, okay, the plane, then it contains the plane vibrations. It contains the direction of vibration. There is a direction is there and the direction of propagation is also there. Okay, there is a direction of vibration and as well as propagation. Propagation and vibrations are there. Vibrations of what? Vibrations of light. Vibrations of light is there. This is called as plane vibration. Okay. Then what is plane polarization? The plane which is perpendicular to this, the plane which is perpendicular to the plane of vibration and it contains direction of propagation. Direction of propagation. There is no vibrations occur. Here the vibration occurs as plane vibrations. Here there is no vibrations. There is no vibrations in plane polarization. There is no change, no vibrations in plane polarization. Then we will step into another one, that is we know the representation of polarized and unpolarized light. This plane polarized light can be produced, this plane polarized light which can be produced by various method. Among that, one method is polarization by reflection. One method is polarization by reflection. Another one is polarization by refraction, polarization by double reflection, double refraction, and selective absorption or dichroism. Then another one is there, the polarization by scattering of light, by scattering of light. The another one is there, selective absorption by selective absorption. So there are 5 methods are there. We will get the plane polarized light. We will get plane polarized light by these methods. One is polarization by reflection, polarization by refraction, polarization by double refraction, and polarization by scattering. The another one is there, that is selective absorption. Okay, now we will discuss about the polarization by reflection. Polarization by reflection. Then the polarization by reflection. Again, this is the surface B. Okay, this polarization of light by reflection on the surface of glass it was discovered by Malus, the scientist Malus, in the year 1808. He found that the polarized light is obtained when the ordinary light is reflected by plain sheet of glass. Consider now light is incident along the path AB. Okay, this is the glass. Okay, the light is falling. This is the glass. The light is falling here. Okay, which will be polarized. How, what happens? So this is the light which is falling on the glass surface, which is unpolarized one, which is unpolarized. Okay, in this direction we know the normal. This is the normal. When light rays falls on the glass surface, it get reflected. Okay, it gets reflected. Okay, when it get reflected, it absorb. Okay, it get reflected in this direction. If it is like this, this is the incident of polarized light, unpolarized light, and this is the reflection of PR, reflection of polarized and polarized light. If suppose if we keep a tourmaline crystal here, the incident ray on the glass slab is there, incident on the glass slab is here. Okay, it get reflected, okay, by an angle IP. It incident at an angle IP and it get reflected by IR, that we know. Here the light is unpolarized one. The light is unpolarized one. When it get reflected, if we keep a tourmaline crystal, the reflected rays get the reflected rays which are plane polarized light, which are absorbed the plane polarized light. Okay, consider a light incident along the path AB. Let's take this as the AB, then which are fall on the glass surface. The light get reflected as BC. In the path BC, the plane tourmaline crystal is rotated slowly. Here the tourmaline crystal is here. I am going to rotate this slowly. It will be observed that the light is completely polarized. Here the light is completely polarized only at a particular angle. Only at a particular angle of incidence. This incidence angle, okay, this incidence angle will be equal to 57.5 degree for the glass surface. Okay, ಇಲ್ಲಿ glass surface ಇದೆ ಅಂದ್ರೆ incident light is here. When it is reflected, when it gets reflected in the direction of the reflected ray, I am going to keep one tourmaline crystal. I am going to slowly rotate this tourmaline crystal. It get reflected, it get polarized at an angle. When it will be when it turns to 57.5 degree, then only we will say the polar light has been completely polarized one. This is known as polarized angle. Okay, then for the glass surface, this is only for the glass surface. Okay, the angle of incidence at which the light reflected light is completely polarized, that is called as polarizing angle. Polarizing angle, which is equal to this. Polarizing angle is, the definition is like this: the angle of incidence at which the light get reflected completely polarized is called as polarizing light. They may ask for the 2 marks question. The production of polarized light by glass is explained as so you have to write like this, explained like this. Okay, then the vibrations of the incident light can be resolved into 2 components, which are parallel to the glass surface and perpendicular to the glass surface. Okay, this component, by this both the component, the glass surface is reflected, whereas light is due to the components of perpendicular to the glass surface. ಇಲ್ಲಿ ಏನಾಗುತ್ತಂದ್ರೆ when light is falls on the glass surface have the glass surface is a component parallel to the glass. The light rays which are parallel to the glass, so that's why it absorbs the parallel, which emits the perpendicular light vibrations. Okay, which are perpendicular to the vibrations ಏನಿರುತ್ತಲ್ಲ ಅದನ್ನು ಟ್ರಾನ್ಸ್ಮಿಟ್ ಮಾಡುತ್ತೆ. So this is about today's class.